Okay, I'm going to solve this. This is basically a problem from general physics. It's a mass on a spring. You have to get the equation of motion and find the speed as it passes through equilibrium. Okay, so let's just write what we're given here. Get the mass is 220 grams. We know the period, 1.3 seconds. The amplitude is 4.5 centimeters, 0.045 meters. At t equals 0, x equals 1.5 centimeters, and it's moving to the right. So at t equals 0, it's moving left. Our velocity is less than 0. Okay. So write the equation of motion that describes the function. So for, we just have a mass here, right? Oscillate. Here's our equilibrium position. At t equals 0, it's to the right, but it's moving to the left, right? And we have a spring attached here. So it's going to oscillate back and forth. Okay. So our equation, a cosine omega t minus phi. Some people did the a cos omega t plus b sine omega t. That's okay as well. But I'm going to show this solution because it's the quickest way. All right, so we need omega, we need phi, we need a. So we're actually given a. That's done. We're given the period. Period is 2 pi over omega. So omega is 2 pi over the period. So 2 pi over 1.3 seconds gives that omega is 4.83 radians per second. Okay, so we got that part. Check. Now we just need phi. So far we have x as a function of time is 0.045 meters cosine omega. I'm just going to drop the units because it gets confusing in there. 4.83 t minus phi. Okay, so now we use our initial conditions to solve for what phi is, because if we put in t equals 0, this term drops out, right? So we know at t equals 0, x equals 0.015 meters. So let's just solve that just generally here first, because I hate carrying all those numbers around. So if we have x at t equals 0 equals a cos omega t minus phi, right? And we're saying we're doing t equals 0, so that term goes away. So we have x over a equals cosine of phi minus phi. And then phi equals negative our cosine or inverse cos of x0 over a. Okay, so we have inverse cosine of x0, which is, we can just leave in centimeters for now, 1.5 centimeters, because our units will cancel by 4.5 centimeters. So that's just a third, like 1 over 3. Okay, so phi equals negative 1.23 radians. We do that in Python. We can just check that. Our cos 1 over 3. 1.23. So by default, Python will return our angles in radians. If we wanted to convert that to degrees, 70 degrees. But we need to put it in radians inside the trig function. Okay, so our equation of motion, x as a function of time, is 0.045 meters cosine 4.83 t minus 1.23 radians. And then actually it's negative phi. So I think that should be a plus. Okay. All right, and then it's asking what's the speed as the mass passes through equilibrium, right? So you got to know when you're in equilibrium, basically you're getting your max velocity, right? Because all the potential energy is zero, all the energy is in kinetic energy. So at the equilibrium, V equals max. So if we look at what our velocity would be, just x dot, we take the derivative of this. So it is minus omega a sine omega t minus phi. Okay, so this is a sine curve. It's a negative sine curve, but that's okay. The amplitude is oscillating between omega a and minus omega a. Okay, so this coefficient here is the max speed that it's going to have. So V max equals omega a. So we have 4.83 radians per second. A is 0.045 meters. So we get our max speed is 0.217 meters per second. Okay, I'm running out of room a little bit. I didn't plan this very well. Okay, so then C was what happens if you add a sail to the cardboard? So our position versus time is going to look something like that. Like we're starting positive, but we're heading in the negative direction. Okay, so if we add a sail, our amplitude is going to drop and the period is going to increase. And it will oscillate back like that. So our period increases. And we could also justify that mathematically. So omega squared is omega 0 squared minus beta squared. So if omega is going down, beta is our damping. This is the undamped frequency. This is going to go down, which means our period is going to go up. Okay, and then if you need to make a pendulum with the same length, so T for the pendulum is 2 pi square root of L over G. So if I get T over 2 pi is the square root of L over G. L is T over 2 pi squared times G. So plug in again, our period is 1.3 seconds, 2 pi, acceleration of gravity is 9.8. Let's do that quick. T is 1.3, so we get T divided by 2 divided by pi squared times G, 0.4195. So we'll say that the length should be 0.42 meters. Okay, kind of squish that in at the end. There you go. It's a Gen Phys problem.